Hey everyone, Nick Dearbird is here teaching you financial modeling. And today we're going to talk about basic data types in Python as part of our segment on going beyond an initial Python script, how we can learn the Python basic tools and skills so that we can go and build financial models using Python. So we've talked a little bit about data types kind of informally so far. We've talked about a few different data types already. We have learned about strings, we've learned about numbers, lists, and booleans so far. And everything in Python is an object, and every object has a type. So this type defines the data structure for whatever object this is, as well as any functions which are attached to that object. And when a function is attached to an object in Python, we call that a method, but still, basically just a function attached to an object. So in order to define how a type, what functions are on the type, what is the data structure for the type, in order to define that, we use a class. And that's going to be the next video, is focusing on classes and how we can define custom types in Python. But for the purposes of this video, we're just going to focus on the basic data types that are built into Python and how we can work with them. So, we already know about strings. We've already used strings. They represent text, characters, and now let's learn a little bit more about things that we can do with those strings. So you might have noticed if you do some calculation, you end up with a number. There might be a lot of decimals on that number, or the idea that you can't just type a percentage into Python, right? Like you have to put it as a decimal, but then you want to have that formatted as a percentage when you display it. And all sorts of other formats. These formatted strings are going to be useful to help us out with that. And also, it can be including whatever your result is as part of a sentence. Mary has 5 years till retirement versus just putting the number 5 out there. So the formatted strings also help with that. And so these formatted or F strings is the same way that you define a string, but then you just put this F on the beginning of it, and that makes it into an F string or a format string, and that gives it this extra functionality that we can just drop other variables or expressions into the string and also tell it how that we want those formatted in the ultimate output. So here's a little example of that. So first doing a short calculation here, just doing 5 divided by 6. And then if you just print that, you just show that result. We're looking at 0.83333333, repeating. And so obviously the output of that does not look great, right? We probably want to round that if we're going to display that to the consumer of our model. And then also, what is this number? What is the context for that number? It's definitely really helpful to include that in a sentence when we display it, or some other kind of way to tell the person who's reading your model what that number actually means. And here, we're just saying my number is because, it's just an example calculation, but in reality, you would want to actually describe what that number is. So you see the result of using this F string is ultimately we get this kind of output. My number is 0.83, and now it does not have all these decimals on it. We can see it only has 2 decimal places. So we can break down how we did this. So you'll notice with this F string, you see we have that F and then the quotes, so that's how we know it's a formatted or an F string, and that means that we can do this. It's not just a normal plain string. And then we have my number is, just like we're going to see in the output. And then here comes the special part. So here we have the curly braces. And within the curly braces, that's where we can do this variable substitution or expression substitution in order to drop our numbers into the middle of a string. So whenever you do the curly braces, that's going to say, here is where I want to put whatever variable or expression. You could even do simple math inside of here or whatever. Call a function or whatever you want to do. Valid, as long as it's valid Python for the most part, it should work in here. And then inside those curly braces is where we put, what we actually want to put into the string. And you'll notice, here as well as, Jupyter and any other editor is going to help you out here. And you notice that this changed color versus the rest of the string, right? The rest of the string is red, signifying that it's just a string. But then this part went black, signifying that it's now looking at the variable mynum and not just a string mynum. So we're going to take this value and we're putting it here in this point in the string. So, if without this extra part, we would get my number is 0.8333333 and so on. If you just did curly braces mynum curly braces, that's without doing any kind of formatting to it. Just put it in there exactly like it would print normally. But then we also want to apply formatting to it. So to apply formatting to it, then we have this colon, and then after the colon, we specify a format code, which says, how do we want to format this number? So what this one here means is we want to have a decimal format. We want to have 2 decimal places, and we want that to be a fixed number of decimal places. So even if you put like 5, just a plain 5 in here, it would come as 5.00 because we have 2 fixed decimal places. And there's a lot of different codes that you have there. It goes beyond just basic numbers. You can also have things like formatting a date or other things. And I have included in the resources a reference that you can look at for all the possible format codes. But for the most part, we're going to use like this fixed, just number of decimals, or we're going to format it as a percentage. Those are going to be the main ways that we're going to use these as far as this class. And when we jump into the Jupyter example, we'll look at a few other things that we can do with strings as well. Then jumping back over to numbers in Python. So we've already talked about numbers in Python. We've already used numbers in Python. But, I've been saying that numbers are a type in Python, but that's actually a bit of a simplification. There are actually 2 main types of numbers in Python. A floating point number and an integer, or float and int would be these 2 main data types for numbers. And the vast majority of the time, you don't have to care whether it's a floating point number or an integer. It really does not matter most of the time, and that's why I've just kind of simplified it so far. But occasionally it does come up, and so it's important to know about it still. And so the difference here is that, an integer, just like going back to, plain old number theory, an integer is, a whole number, 1, 2, 3, negative 1, 2, 3, 0. It doesn't have any decimals. Whereas a floating point number does have decimals. So even if it's 0, even if all the decimals are 0, if it has decimals, it becomes a floating point number. So that's why if you look at a couple examples here, so 3.5, that's a floating point number, a float. 3.0, you might think that's an integer, but actually it's a float as well because we did 0.0. Even though, that's 3, it's the exact same value as the integer. Because we did that 0.0, that makes it actually change the data type to a floating point number rather than the integer. It's only if we just put the integer part of it, just a 3, then it becomes an integer. So, and you can compare across floats and ints just fine. If we do 3.0, is that equal to 3? That'll return true. Those are definitely equal, and yet they have different data types. And so again, most of the time this doesn't matter, but one instance where we are going to run in that it does matter is if you want to loop a certain number of times, and we'll look at that in the Jupyter example, how we do that. Say we just want to loop 5 times, you cannot give it a float, you can only give it an integer, because looping 5.6 times doesn't mean anything, right? Like, what do you do for that 0.6 loop? And so Python has restricted it so that it only will take an integer, because those would be the sensical values for that. So if you try to pass it a float, then you'll get an error about that, and we'll see an example of that in the Jupyter notebook. And then we'll just introduce a couple additional built-in types, and these are both like container types. They hold other objects. So one here is a tuple, and a tuple you can think of as, it's basically a list. It holds items, they're ordered, you can look them up by index. But the one main difference between a tuple and a list is that with the list, you can create it with whatever items, and then you can add items, you can remove items, whereas the tuple cannot be changed after it's created. Whatever you have in there when you create it is going to be what's always in that tuple. You cannot append, you cannot insert, you cannot remove, and so it's always what you started with. And the difference in specifying it is that you're going to use parentheses instead of square brackets. So this here would be a tuple of A and B. And generally you're just going to want to use tuples if it's some instance where you don't need to change the items. And if it is some instance where you are going to need to change it as you go through your code, then you want to use a list instead. So not a huge difference, but it's definitely a nice little extra protection that if you're expecting that this it shouldn't change at all, if you use a list for that, you could accidentally append to it or remove from it, and that could mess up all your other code. So it's just a little bit safer to use tuples, and they are more performant as well. Then the other data type that we're introducing here is a dictionary, or dict. And so that is a mapping of values to other values. So you could map A to 1, and then you can go back to this dictionary and look up what's the value for A, and you're going to get 1, is the basic idea behind them. And we're not going to use them immediately, other than just introducing them and playing around with them, understanding how to use them. But we will definitely use them as we proceed throughout the course, so I wanted to introduce them now, since they are a very fundamental data type in Python. So with that, we can jump over to the Jupyter example. So first, going back to strings here. So again, you define it with quotes, then you're going to get a string, right? So we have that string, ABC, and we have the type of that being a string. And one thing which we haven't mentioned before is you do have an option of whether you want to use single quotes, as I have been using, or you can use double quotes for that as well. It does the same thing, and so it doesn't really matter which one you use. Now, you don't want to mix them. You don't want to do a single quote and then a double quote. That is going to get you a syntax error. So watch for that. Typically just pick one style and stick with it. It really doesn't matter too much. The only time that I ever make a conscious decision of which one I'm going to use is if I want to use the other mark inside the string, right? So here I wanted to use a single quote inside the string, and so I use double quotes on the outside. If I use single quotes on the outside for that, then, I mean, you can see already that it's messed up just looking at the coloring here. And again, we're going to get a syntax error because it interprets the string ending here, and then from here it starts to interpret these as just variables, and yeah, it can't, this is not valid Python at this point. You can work with that by putting a backslash there. That escapes the quote, and then we're back to what we had before. But I think it's, you know, if you know you're going to use a single quote, then just put double quotes on the outside. That's a little bit clearer. And then if you know you're going to have to use double quotes, then again, you would want single quotes on the outside to make sure that you don't have any issues there. But beyond that, it really does not matter. Just pick one and stick with it consistently. Make sure that you have the same character on both sides of the string for it to be valid. So there's a lot that we can do with strings. And so if you want to look at, you know, all the things that you can do, then you just can, you know, do dot after the string and then hit tab, and then Jupyter is going to pop up all the possible things that you can do here. So there's tons here, and we're not going to use the vast majority of it in the course, but it's all there. You know, basically, if you think, you know, how do I capitalize a string? Well, you can, you know, just scroll through these and look for what, you know, makes sense. Oh, a dot capitalized. Yeah, that sounds right. Now I can see that it got capitalized at the beginning. But what if, you know, I don't know, I want to get it to all uppercase, and I don't know, you know, again, I could look through the methods and try and pick it out. But definitely, you know, Google is your friend. Python string to all uppercase or all caps. Let's do that. So then we can see some results coming up. Oh, string.upper. Maybe that's what we need. Oh, string.upper. Okay, that's what we can do. So then we put upper there instead. And we can see that does indeed work. So definitely Google is your friend for finding out what you can do in Python. There are so many resources out there. There are millions and millions of people out there who work with Python. And so it's really easy to find help for, you know, how do I do this particular thing? Just Google it. You're most likely going to find some kind of answer. And then don't really worry about this code. This was just so that in the notebook I could have printed out all these different methods that we have on the string. And then, you know, here my A is all lowercase, so, you know, is lower, I can check if it's all lowercase. So, you know, these are just more examples of things you can do with the strings. But there's so many things here, and you can just Google for whenever you need to do anything in particular. So moving on to numbers. So again, it's not just numbers, we have floats and ints in Python. So 3.5 is a float, 3.0 is a float, 3 is an int, even though 3 is equal to 3.0. We can see that the types themselves are not equal, even though the values are equal. So again, it doesn't really matter most of the time whether you have floats or integers. You know, you can go and you can do math, you know, with one being a float and one being the integer. It doesn't matter. Where it does matter is when we want to loop a certain number of times. And there are other places as well, but, you know, probably we're not really going to hit them in the course. This is the one that I know is going to come up in the course. So here is a basic way that we can do a loop for a number of times. This is the built-in function range. You give range a number, and it's basically like making a list in the background of all the numbers leading up to that point. Not exactly It's not actually a list, it's a generator, but we don't need to worry about that. We can think of it as a list, and effectively for our purposes it works like creating a list with, here it would be 0, 1, 2, 3, 4. So again, that 0 based indexing, it's going to start from 0 on the first one, and it's going to reach ultimately the 5th number, which is 4. So then if we do want to get, starting from 1 instead, you can either, just add 1 to the number. Here's also showing that we can put an actual expression inside one of these f strings. It doesn't just have to be a variable. We also don't need to have the format part. We can have just the value itself. Here the value didn't need formatting, and so we left it off. And so you can do it that way, or you can instead, start the range from 1 and then go to 1 higher than where you actually want to go. That will also get you the 1-based indexing there. But anyway, so that's how you can run a loop for a certain number of times. But let's say that we we had let's see, num loops equals 10 divided by 2, and so okay, yeah, that should be 5 loops, right? And then we put that there. We're going to get this float object cannot be interpreted as an integer because this num loops came as a float. Any result of division is going to be a float, and so this is not going to work. You need to pass an integer here, even though the value of that is 5, and we check, is it equal to 5? Yeah, why doesn't this work, right? But it's because it's not an integer. So there is a very easy way to fix this. If you take this, we have this num loops, which is a float, but if we take the integer of num loops, then that will get us back to having an integer. So we just wrap it in int, and then we're going to have an integer come out of that. You do need to be careful with that because that will kind of do the floor. If you do int of 5.6, that's going to give you 5, right? You are losing information there. So you want to make sure to only do that if you know that it's a whole number anyway, or you don't care about this part of the number. But it is a solution for this because we know this is going to be a whole number. It's just coming as a float. We just put this in an int as well. And now all of a sudden this works just fine. So that's the additional material on numbers, and now let's look at tuples. So again, tuples, work a lot like lists. You can index them, you can loop through them just like lists, but you just can't add or remove items. So here I'm going to define my tup as 1, 2, 3. So we have these 3 numbers into this tuple. That's one way you can create a tuple. Another way is, if you already had a list, you can convert that list into a tuple. So here I have a list ABC, and now I'm doing tuple of my list. So here another built-in function tuple, and that's converting that list into a tuple now. Now that list still exists, you already defined it, it's still there, but you just now also have this tuple separately, which you're not going to be able to add or remove items. And then, the same thing works for converting from tuples into lists. If you wrap, whatever in list, then it's going to convert it to a list. So here we went from a list to a tuple and back to a list. Really just for sake of example here, you wouldn't normally just be going back and forth for no reason, but just showing that you can easily convert back and forth between lists and tuples. Now we know that we define lists like we can do a equals 5, 6, 7 or whatever, and then that's going to give us 5, 6, 7. Also, if you just have that 5 in there, then that also works just fine. The type of that is still going to be a list. But you do need to be careful with tuples. When you create a tuple, also, if you have multiple items, you don't really have to think about it. It'll work fine. The issue is creating a tuple with a single item in it. Because if you want to create a tuple with a single item, you do have to put a trailing comma on it so that Python knows that it's a tuple. So this here is going to create a tuple, whereas this here is not going to create a tuple. Even though you think, I put the parentheses, it should be a tuple. If there's only a single item, you do need that trailing comma. So you can see actually it's not coming as the tuple of A anymore, it's coming as just A, and it's coming as just a string. And that's because, tuples are not the only meaning of parentheses in Python. Parentheses in Python can also be used to group things for, like order of operations purposes. So here we basically made a group which has just A in it, which just then again evaluates to A. Instead of what we intended to do, which was make a tuple, there you do need the comma to say that it's a tuple. But just like lists, you can index them. So my second tuple again was ABC. So 0 is going to give us the first item up until a -1 gives us everyone with the last item. So the indexing all works exactly the same as it does for lists. You can also loop through them just like lists. So that works just fine. The one thing that you can't do is you can't go and try and append to it. So let's try and append 10. Oh, wait. Tuple object has no attribute append, right? Because you can't add anything to an existing tuple. So that's tuples. And then the other totally new data type we're looking at here is dictionary. So dictionaries, and it's going to be, dict is how it's, talked about in Python. So that's a mapping of items to other items, objects to other objects. And so, here's an example, and you can define the dictionary with these curly braces. So what this is saying is we have a dictionary, and we have the key A mapped to the value 1, and we have the key B mapped to the value 2. So it's whatever, two things you want to associate with each other. You put the key first, so the key is what we're going to be able to look things up by, and then you put a colon, and then you put what you want the value, or what is the result of looking up by the key. So let's make that a little bit more concrete. So I've got my dictionary here. A is associated with 1, B is associated with 2. That means we can go and we can look up the value for A. And here, we say, give me the value for A out of my dictionary, and we get 1 because 1 was associated with A. Similarly, we can look up B, and it's going to give us the value 2 because that was the value associated with B. And if you try to look up a key which is not there, then you're going to get a key error because it cannot find that key in the dictionary. And also, you cannot look up by the value. You cannot look up 1 and expect to get A. There are definitely ways to reverse the dictionary and make it look up the opposite way, but just basic usage, you look up by the keys and you get the values as a result. Look up by A and B, get 1 and 2, not the other way around. So we'll definitely do a fair amount more with dictionaries as we go through the course, but I just wanted to kind of introduce them very quickly here, just so you're familiar with the idea of them, and we'll build on that more later. So the last topic that I want to talk about within the basic data types is this concept that, again, everything in Python is an object. And so everything is kind of treated in the same way. And that allows you to have any kind of nesting of data types that you want. You can have very complex nested data structures just based out of these basic data types. So for an example, a very common one of these types of data structures is to have a list of dictionaries. So then, each dictionary is representing like some kind of entity. Here, each dictionary is representing a person, and we have multiple people. So each dictionary is one person, and then we have multiple people in the inputs list. And then within the dictionary, we have, some different characteristics of this person. So name and weight are the two characteristics that we're tracking here. And so for John, we have that his name is John, of course, and then that his weight is 180. And for the other one, the name is Sarah and the weight's 140. So then you can do something like loop through this inputs list so that this input variable that we're getting here is the entire dictionary itself. And then we want to pull the name out of the dictionary and the weight out of the dictionary to display details about each of these people. So then, this is each of these people introducing themselves. For whatever reason, they introduce themselves by saying their weight. But the basic idea here is you can work with any kind of nested data structure. And you can take this to any level that you want. So here's a more complicated example. So again, it's a list of dictionaries where each dictionary represents a person, but now also each person has friends associated with them. And so then friends is itself a list of dictionaries, which again represent more people. And then for each of those people, it says the activities that they have shared with the original outer person here. So definitely a more complicated data structure to work with here, but the idea that you can continue to nest these things as many times as you want for whatever data structure makes sense for the particular problem that you're working on. So here's, for the point that we're at in our Python learning, this is kind of a lot going on here. I don't expect you to understand this whole block of code right now. If you take the time and really go through it, you can definitely figure it out. But mainly here, I'm just trying to highlight that you can work with these nested data structures. And so here I'm ultimately printing, for each person, who they hang out with and what they do together. And so, Sarah here has two friends, and we see two statements for Sarah. And then I made it also, if it's not the first person, then it's going to say they also hang out with. So yeah, you can, have any kind of arbitrary logic that works with any kind of data structure. Things are very flexible in that sense in Python. So that finishes up the material for the basic data types in Python. Next time, we're going to talk about creating our own custom data types by using Python classes. So thanks for listening, and see you next time.